didn't push play. It was already running.
Which one? This one?
This one, yeah.
No, this one, I just loaded this one.
Okay, it's directly loading like this.
Yeah. It's like this. So you might not recognize the script because here there are two versions, the vectorized and the sequential. I think in the demo, so inputs to my so there is a big loop here, so it's going to run for every 100 milliseconds. So my inputs are the indicators here in LabVIEW, which come in here and there, and they're all going to my side of script, which demo in Scilab create two vectors, which are going to be x and y, and I'm going to do it in two ways, calculating the coordinates of the points. One way is going to be vectorized, and another one is going to be sequential. I'm even generating after I got my two vectors, a matrix, two matrices, a map1 and map2, and which will give me, by adding them both, my ending z, which are going to be the altitudes. And so it's very easy to do. I could have even do it z equals repmat1 plus repmat2, but this is an easy and readable way to do it. And in a sequential way, this is a very bad practice in Scilab. Marco, if you're an experienced user, you may know that in Scilab you should not be using sequential loops such as for and while loops, because it's Scilab is an interpreted language. It's just a gateway to compile code, such as C, C++. So when you do a for or while loop, you just loop from the Scilab gateway layer to the compile code layer. You do that as many times as you have it one.
For those who don't know much about the grammar of Scilab here, if you have double slashes, it means that it's been commented, so it's not going to run. So you're just going to run the vectorized.
Yeah, it's been commented out, so vectorized and sequential are not going to be
These are commentars, so
yeah,
it's just going to run the vectorized version.
Right. So and so in Scilab, as you can see, those are my inputs and those are my outputs. I hope there is not too much lag, so when I show you something on the screen, I hope you can see it at the same time.
Otherwise, we'll be maybe tweaking the sampling.
Yeah, we might.
Because in between there's the internet, so you might not see it at the same rates as we see it on our screen.
Just tell us if it's trouble, otherwise we'll keep on going. So when I launch the demo, this is what I get. So on your screen, it's like the sampling seems to be 0.5 seconds or something like that. On my screen, I promise you, it's perfectly fluid. It's it still runs very, very fast.
Or maybe you want to slow it down so that we can see it actually slowing it down on screen. No, minus is 0.
Yeah, sorry.
So if you go to 0, it's going really slow, and now it should be.
It's very smooth on my computer. Anyway, so I can tweak the magnitudes as well. So you can have let's say 0 in
beautiful waves.
So this is the kind of thing that you can do. So here you're not benefiting from the graphical capabilities of Scilab because it's all done through a demonstration showing that in Scilab you can benefit from the vectorizing abilities of Scilab, which is if you're an experienced Scilab user, this is very fast. It runs very fast. It's very readable. That's also a point for it.
Capabilities. You can also basically just use this scripting capabilities of Scilab, which is good to design, for example, filters. If you want to design your own filter, then you can script it within this script, and then basically it gives you more flexibility than just LabVIEW blocks.
So you don't have to translate
it
into LabVIEW. You can just paste it there. Okay, so let's move on to the next next demonstration, which is a bit more interesting because it's not just to show the basics. Right, okay, this is very common. It's good. All right. Okay, this is a very common amplitude modulation example. So you have a carrier signal. You start with a carrier signal. You have a message that you modulate, and so those are going to be the two first inputs, and this is.
It's alright. Just go on.
Okay, so here in LabVIEW, I have added a bit of comments so you can see how the flow goes. So on top you have the carrier and the bottom the message. And in Scilab this is done in just a couple of lines. So you have you build your vector. Is that your question? I mean, is it useful to use plotting capabilities in LabVIEW? The question only means something if you compare it to the Scilab. All right. Okay. Sorry. Okay. I would say it depends what you do, but in Scilab, surely. So it depends on what you want to do. But if you want to do Bode plots or Nyquist or even stuff like that are related to signal processing functions, graphical signal processing functions, you may use them in your Scilab. So this is. Of course, what I showed in just the plot 3D makes no sense in itself. but we have plenty of signal processing graphical functions. So those make sense to use in LabVIEW inside a script.
Also, besides of the plots, you get some capabilities within Scilab to play with your plots. You can export it, titles, and I think it's gonna do so well on LabVIEW. You get an environment within Scilab where you can get the graphic handle with axes and change the colors and make some modification on your plots.
What you might want to do for that, it's running an instance of Scilab, just double-clicking on your Scilab on your desktop, Scilab demonstrations, and in the Scilab graphics sections, you will find all the features, the graphical features of Scilab, some related to signal processing. So that might give you a pointer on all the functions that you can use inside LabVIEW, which might wrap up what you want to do, or the kind of graphical window. So in Scilab, when you have a graphical window already open, you can get a handle on it and modify it by script.
Was it also an answer to your question of Jan? So Jan was also asking how you can Scilab graphics from within LabVIEW program, and I think it was basically the first demo that you did.
That was the second. Yeah, I'm sorry. The first demonstration. Yes, so it's called a Scilab version. I think the VI inside when you install the LabVIEw the gateway, it's called a Scilab version. It gives you information about your Scilab, the Scilab installed on your system, and it also calls plot 3D, which pops up a 3D window. So yes, you can.
It's pretty simple. And also, if you just drag and drop a script, a Scilab script within LabVIEW, and just write down the plot command, then you would also directly get a plot, not a plot 3D, but a plot,
which is what I did
demo.
in the demo.
You did the plot 3D. You can also have
yeah.
Just basically pop up of the Scilab graphics just with.
For instance, if you just type in plot, you have a subplot which is in one window, two different graphics, two axes, you could say. One on top and one in the bottom, which shows you the kind of thing that you can do in Scilab.
Yeah, this is also something that we can mention as a capability of Scilab. You can, within your graphic window, you can also make some different, add up some different, get the handle that you have on the graphics. You can do quite a lot of things.
Just run your Scilab demonstration in a Scilab instance.
Yeah,
and it's going to tell you plenty about it.
Yeah, so if you just open Scilab itself, you can go to the demonstration. You do demos on graphics in Scilab. You've got not only the graphics as a simple plot, but also some demos on graphical user interface. This is also a capability of Scilab to adapt to your script some graphical user interface with some sliders, but here directly within Scilab.
Any other question, or are we good?
I think Michael is.
We have time, guys. So if you wanna, we have time. You're welcome. Thank you for your feedback, Michael. And so, as I said, our proceedings on that are going to be based on the interest that the community is showing. So it's up to you to tell us if it's worthwhile for us continuing the developments on the gateway.
So here, also, but the webinar, it is we recorded this session, so we will be posting it on YouTube or some other video platform. So if you want to review it in the future, something you did not quite understand, so yeah, we'll post the link on the social networks and we'll send it to you also as a follow-up. Also, yeah, as Paul was mentioning, we will be considering further webinars. Some ideas, some specific. We were considering, for example, some modeling, system modeling, and simulation of dynamic system, for example, with XCOS, because Paul is also an expert in XCOS, so it could be a further session of webinar.
Compared with MATLAB and Simulink, that's if you have a MATLAB on your computer, which is not the case for me. I don't have 10,000 euros to compare it, so I cannot tell you. I didn't make the comparison with MATLAB, honestly.
Yeah, I didn't quite understand the question of James, the comparison with MATLAB and Simulink. Well, this is something that we can maybe discuss directly about this comparison of the features of Scilab with MATLAB. The question of was how I understood it. How can we connect directly this VISA toolbox to XCOS, to Scilab? So basically, XCOS it's working as a let's say an overlay, or it's built on top of Scilab. So if you can get your signal thanks to the VISA toolbox directly within Scilab, you can also write a specific block in XCOS with Scilab code in it, stating, for example, get data. And it's kind of a similar function in the VISA toolbox to get your data, and it will get you the data from the Scilab environment in XCOS. So basically, I don't know if it's what you meant by VISA to XCOS to Scilab, but it's it is.
I see two ways to that. Two ways to do it in XCOS. It's first you can as Jan mentioned, you can write Scilab instructions within XCOS. So you have aside from that, you just want it as an input, like you want to import from Scilab an input to XCOS. So use an input of Scilab inside XCOS. There is a block called from workspace, which lets you first compute values with visas, and if you want to inject them inside XCOS, you can use the from workspace block that lets you inject values inside XCOS. So I hope I answered it in two ways possible.
Oh, James, mixed complementary optimization.
James,
I'm not quite sure what you mean by that.
Optimization features inside the Scilab script block in LabVIEW. If that's your question, then yes, of course. Again, go to the of course. Go to Scilab demonstrations. Look up the optimization section, and all the functions that are present there will be present in your LabVIEW block. As I said earlier, we have not identified any limitation. There might be ones because we've not tested all the functions. Of course, in the you see that the demos that I wrote were pretty basics. So I have not tested, for instance, the optimization. So I'm sure they are present because I don't see why they wouldn't be. There would be no reason for it. But since they're present in a standalone,
and actually optimization is a field where Scilab is pretty good compared to MATLAB. We've got a lot of function in linear, non-linear optimization also, as I mentioned earlier with the case of Dassault Aviation, some genetic algorithm, and also simulated annealing. So yeah, this would be actually the idea to leverage these capabilities of Scilab optimization within LabVIEW script, and this would be definitely a field where both software are good complement and complementary. So I think we will for today, and well, thank you all of you for participating, for asking and asking questions, and for your interest. And as I mentioned, we will send you a small email just as a follow-up, and maybe we can speak also directly in order to have your feedback on the webinar and on the subject of test and measurement.
It's very nice to have a direct interface with our users. So thank you very much for tuning in and for listening, taking the time. So it was a pleasure for us as well.
Well, and if you want a session of this webinar in English at three. Thank you very much.
Bye.